Alrighty folks, this is volume of similar figures. We're continuing on into 1.5, and you know what, I was really going to try to do a Scottish accent, but without the costume on, it's just not working. Can't even bring myself to try and do it. So if you're waiting for that, sorry, not going to happen. Anyways, looking at volume then is just kind of continuation of what we were doing so far with area. If we remember, we discussed in class that because we measure length in centimeters, the perimeter is also in centimeters. That's a 1-to-1 ratio. For area or surface area, we measure that in centimeters squared. So that's a squared ratio. And then for volume then, because it is measured in centimeters cubed, we'd expect a cubic ratio. So just looking at the ratio for these two cubes here, I think you can see that for the length, it's a 1-to-3 ratio for the side length. So really quickly then, why don't you write down or guess what the surface area ratio would be between the two of them. Hopefully you said 1-to-9 because that is the right answer. And just to prove it to ourselves, we're going to work out what the surface area is really quickly. Well, I'll do it for you. And so we get 96 centimeters squared for the smaller one and 864 centimeters squared for the larger one. Just 6 times the area of one face because they're all identical faces. And if you look at the ratio there, it most certainly is a 1-to-9 ratio. So that definitely does work. The question then is the volume ratio then going to be that cubic relationship that I told you about? So if we're cubing the ratio, what would that give you? So hopefully you said in your mind or out loud or something that it'd be a 1-to-27 ratio because 3 cubed is 27. 3 times 3 is 9. 9 times 3 is 27. Well, does that actually work? Well, let's have a look here. Okay, well the volume of a cube is just the side length cubed, so 64 centimeters cubed. If I wanted to find the volume of this larger cube, I could say, well, it's going to be this side here times 3, so 3 times 4, and then this side here, whoops, sorry about that, this side here times 4, so or times 3 rather, so 3 times 4, times the depth, which is this one here, also times 3. Okay, in other words, I'm doing 3 times 3 times 3, which is 27 times 4 cubed. Okay, so just again showing you that it does actually work out. The other way you could solve it obviously is just to multiply 12 by itself 3 times. Okay, which is simply going to be 1,728 cubic centimeters. And the question is that a 1-to-27 ratio? Well, let's find out. And obviously the answer is a resounding yes, it is. And so yeah, that is a 1-to-27 ratio, so that does hold true. So there you go. For a length ratio of 1 to whatever, let's say 1 to 3 in this example, the perimeter ratio would also be 1 to 3. The surface area would be ratio rather would be 1-to-9 because that's 1/3 squared. For volume, it'd be 1/3 cubed, so 1-to-27. And that works, that extends into all the other types of problems that we did. So let me kind of throw another question up here for you, and you can try this one on your own in just a sec. Okay, so here's an example with two similar cylinders. The radius of one is 3, the larger one is 7 there, obviously. And if I gave you the surface area of the small cylinder, as well as its volume and the height, can you find the surface area, the volume, and the height of the larger cylinder? Go ahead and give it a shot. The next video I'm going to go over the answer.